Saxon Advanced Math, Lesson 60.b. This is loss of solutions caused by division. They gave you an example right off the back here of a problem that is going to lose some of the solution. So I'm going to show you, this is their problem, and I'm going to go ahead and show you a little sidebar here to begin with. So if I took 2 sine of x, cosine of x equals the sine of x, and I just rewrote that here. This is their example problem. If I took this and I divided both sides by the sine of x, which I can do because I'm dividing both sides, but I'm dividing by the same argument on both sides, I'm left with 2 cosine of x equals 1. And then that gives me, moving 1 over, 2 cosine of x minus 1 equals 0. This is where they would have picked up and got an answer. And that's fine, but we're going to find out we're missing a couple of answers here once we do that. So let's go back and look at this if I did not divide both sides by the sine of x. So the first thing I did is move the sine of x to the left-hand side by subtracting. That gives me 2 sine x cosine x minus the sine of x equals 0. At this point, we'll use what we learned in the first half of this lesson. We're going to factor the sine x out of both sides of these terms. So I pull that out to the front, and I'm left with a 2 cosine of x from here. And then I took the sine of x and divided by the sine of x, that left me with 1. At this point, I realized that the sine of x equals 0, or the 2 cosine of x minus 1 equals 0. So I split it, like we did in the first half of this lesson, into 2 different directions and say, well, the sine of x equals 0, that's one option, or 2 cosine of x minus 1 equals 0. Now, at this point, I want you to notice that if we would have done the first thing that I mentioned to do, which was divide both sides by the sine of x, we would have lost this set of answers. They're gone. Because even though we didn't violate any rules of algebra, we lost some of the answers. And sometimes when you divide both sides by the argument, you lose part of the answer. So on this case here, we're picking back up where this problem's at. We take the sine x of theta equals 0. Well, what is the sine of x equals 0? Well, there's only 2 possibilities for that. That's 0 and 180. If I go to the other side and I say 2 cosine of x minus 1 equals 0, I would have taken this back. I move the 1 back to the right-hand side, divide both sides by 2, and I end up with cosine of x equals 1/2. Well, where does the cosine of x equal 1/2? Well, it's a special triangle, 30, 60, 90, and there's only 2 quadrants that are going to be positive for the cosine. All students take calculus, is our acronym for that, and we realize that, so it's going to be in the first and the fourth quadrant. A first quadrant cosine of 1/2, was adjacent over hypotenuse, is a 1, 2, root 3, right? 1, 2, root 3 triangle, which means it's a 60-degree angle. And that also puts me in the fourth quadrant with a 60-degree angle. Well, 60 degrees in the fourth quadrant is really 300 degrees, so I have a 300-degree answer as well. So my answers are 0, 3, 180, and 300. If I wouldn't have done it this way, and I would have divide both sides by the sine of x first, I would have lost these 2 answers. Now, let's see if we can put this into perspective. If I said even a really simple problem like x times y equals 2y, if I divided both sides by y to begin with, I'm going to get x equals 2 and I'm done, right? The problem is there's all these other values that y could have been. And that's why we're having to do this with this setup here, with I'm not dividing by the same argument on both sides and canceling it out. I'm going to move it to the left, factor it, and that gives me this set of answers that I wouldn't have had before if I divided first.